Hello, my name is Alexander, and this is the video presentation on my BoostedBreakCAN project. This is my attempt to reverse engineer the CANBus protocol that exists between Boosted Board ESCs and batteries. Right here shown is my test bench setup. It's a Mini X ESC hooked up to an extended range battery through my Higo extension breakout cable. Everything's electrically connected as would be on a normal board, except we have some extra lines coming off of it. The important ones are the CAN high and low, the green and yellow wires that will go to my peak USB CAN adapter right here. That plugs into my laptop, which can run BoostedBreakCAN. This is the GitHub splash page for BoostedBreakCAN. I will have a link to that below, along with a link to the overall Boosted Break project. I hope to reverse engineer most of Boosted Board products from the ground up. It's a work in progress, but I'm very hopeful. So if you're interested in checking that out, that will be below. Now I'm going to show you BoostedBreakCAN in action. This is the project loaded in Visual Studio, and we will run. It's a Visual C++ application. This is the first thing that I'll show. It's the PCAN basic initialization. The important line is the bottom one, PCAN basic successfully initialized. That tells us that the USB adapter is ready to go. Press any key to continue, and this is the startup page for BoostedBreakCAN. This is the table view. This shows every message that I've ever encountered through my reverse engineering. So right now there's no traffic because the board isn't on. So let's change that. Go over to the battery with one hand. Let me turn it on. Green light, good sign. There we go. If we go back to BoostedBreakCAN, this is a live view of the CANBus messages going back and forth between the ESC and the battery. Some messages to mention. Battery will send voltages, amperages, state of charge, current timestamp to the ESC. And the ESC will send ping power commands as well as the current speed mode back to the battery. Most messages are the battery going to the ESC. The ESC seems to be the main circuit board on any given Boosted Board product. So as I said, this can decode messages in real time. Of course, the board is on the bench, so I'm not going to actually ride it. But one thing I can do to interact with it is push the power button on the battery. So if I triple tap this, 1, 2, 3, the battery will actually let the ESC know the button status. If you look at the bottom message, XRB button state, you'll see that the last sent message was a notification to the ESC that the XRB's button was pressed 3 times. Which is pretty cool. I can show you again, except this time have the camera focus on BoostedBreakCAN. I will double tap it this time, 1, 2, and it'll say press twice. So pretty cool. So yeah, as I said, in this state, the BoostedBreakCAN project is acting as simply a listener of the CANBus messages going back and forth. It can also emulate an ESC and fool a battery into giving power. So I will demonstrate that as well. I'm going to quickly turn off the board as is. You'll notice that a CANBus message will notify the ESC why the XRB is shutting down. That battery state timer millis LSB message will say it's shutting down, and the reason was the power button being held, which is exactly what I just did. So pretty cool. I'm going to clear the table view, and then I'm going to disconnect the ESC from the battery. There you go. Just like that. So the only thing electrically going on here, the battery is on its own, but the output sense wire is shorted to ground. I have this little switch to help me do that. That is kind of the basic physical indicator to the battery whether an ESC is connected. So we first need to do that to think that an ESC is connected, but you'll need to do more. It won't be fooled right away. It needs to see some CANBus messages and pings in order for it to think the ESC is alive and connected. Excuse me. Okay. I'm going to go back to BoostedBreakCAN. I'm going to press the button to emulate the ESC. There's a mild visual bug, which I'm looking to fix, but functionally we are going to emulate the ESC. We're simply waiting for the battery to power up and send some messages to get us started. So to do that, I will again power up the battery right here. There we go. So I'm going to keep it focused on the battery because without doing the CAN bus messages, if you short the sense line, by now the battery will let you know that it's not fooled, that it thinks an ESC is connected. Normally you'd see a yellow light and then the three middle state of charge indicators will be lit. But of course right now we're still green. It's successfully being fooled thinking that an ESC is connected when that is certainly not the case. The only thing that's connected is the CAN wires and the HEGO connector going to my PCAN adapter right here, plugged in my laptop, who is telling the PCAN adapter to send certain messages at certain times to, again, fool the battery into thinking it's an ESC. So yeah, this is actively working. There's not too much to do with a laptop to interact with the battery except one thing, which is to tell it to power off. So I'm going to focus back on the battery. You'll see the green light is still present. There we go, which is what we'd expect. I'm going to push the button on my laptop and keep it focused on the battery. And when I press the button to send the power off command, you'll see that the battery will shut off. There you go, right there. So this basically simulates the same, this is the same thing that happens under normal cases when you turn off the board by holding reverse on the remote and holding down the power button on the remote. If you didn't know that, that's one way you can turn off the board and the remote at the same time. And so in that case, the ESC sends specific commands that my PCAN adapter can send as well. And so the battery will turn off in that case. So yeah, this was intended to be a brief presentation, visual representation of my BoostedBreakCAN project. I know that not too many people own PCAN adapters, so I figured I would show a little video showing everybody how it works and what it looks like. Again, all links can be found in the description below for Boosted Break as a whole. I want to do a specific shout out to David Wang, aka technically a nomad of XR General Hospital fame, for helping me source the HEGO extension cable. Thank you for that. And if you are interested, you have any questions, concerns, or are interested in contributing to Boosted Break, please reach out to me either in the comments section of this video or on the Boosted Board Reddit page or on the XR General Hospital Discord server. I will have links to my my accounts there if you guys are interested. So yeah, thank you so much for watching. Feel free to check out any of my other videos if you're interested in other things I've worked on in the past, and I'm hoping to have more videos to share the more reverse engineering I get to do on these boosted boards. So yeah, thanks again and have a good one.